Bismillahirrahmanirrahim. Let us look into this integral first of all. So far we have been using the technique of integration, what we call as the Usubstitution. So for this question, can we use the Usubstitution technique? So if you are to use the Usubstitution, let's take the denominator value. Let's assign it as a U. Alright, so we need to substitute everything in terms of U. So to replace the dx and get the du, we need to differentiate. Okay, du dx, and here the derivative of 81 plus x squared is 0 plus 2x. Okay, so the dx there, as we rearranging it, it becomes du over 2x, and then we substitute. Alright, so 1 over u. Okay, dx, what is the dx? Let's replace the dx. So dx is actually du over 2x. Let's bring the 2 up front, it's a constant. And here we have x. Okay, so how to replace the x? The x is, you can take it from here. So, for example, x squared is, as we rearranging it, it becomes u minus 81. X is the radical of u minus 81. Let's substitute it further. Okay. So, 1 over u. X just now is the radical of u minus 81 du. Now it becomes more complicated than this, right? So, we are stuck. And in fact, if you have two variables here, okay, u and x, you cannot integrate straight away because there are two variables. But as you are replacing your x from here, okay, that you take from this u, your integral will become complicated. So I would like to show to you a wrong way to solve it. Sometimes, okay, this is a wrong solution. Okay. So please avoid this. Okay, what happened was, in order to integrate, coming back to that question, and we are stuck with the x there. Sometimes I notice that a wrong way to solve, they relate or they put the x outside. Okay. And then integrating 1 on u. Integrating 1 on u. If you are using this, you cannot use this formula, but this is the integral of the 1 on u, which is ln u. But this is, as I said, a wrong answer. Why? X is not a constant. So you cannot just simply take in front or assume the x to become a constant. So this is a wrong answer. So in that case, coming back to the question, how do we integrate this form of the function? So let's learn another technique of the integral. So coming back to the question just now, how do we integrate 1 over 81 plus x squared? We need to have formulas. So up to your level, we have 3 forms of the formula given in our formula list. If you have to integrate something like this, 1 over a squared plus u squared du, okay, the answer is this one. It is an inverse trigonometry answer. Okay? And if you have a format of 1 over radical of a squared minus u squared, second formula, okay, second form, okay, your answer is given as inverse sign. Okay, you just need to recognize what is the u and the a. Okay. And the third one, if you have an integral of 1 over u and then multiply by the radical u squared minus a squared du, so that is the answer. Okay, so basically there are 2 forms of a format for the integral with the answer that we need to use. So another to see on how do we solve it, we need to compare to the solution given. Okay. So like this one A, compared to the answer given or the format given, this is look like form of number 1. Okay, format of number 1, where the A square is 81. Hence the A is radical of 81 is 9. So recognize the A, then we can just put the answer as if the answers are given. Okay, 1 over A is being 9, inverse tangent U, our U here is x variable over the A 9, and this is indefinite integral, put the constant of your integral plus C. Easy, right? Okay. Next, let's look at B, question B. How do we integrate 1 over square root 6 minus x squared? Again, compare. The format of this question B is like format number 2. We just need to recognize what is the A squared, that is 6, so meaning A is square root 6. So the answer for this integral is inverse sine U, our U is x, over A here is square root 6, and plus C. That's it. Next, let's look at question C. How to integrate 1 over square root. Now we don't have a simple x squared or U squared. Okay, if you notice, the integral here is in a form of a constant square minus or plus U square, a single U. Okay, over here we have a 16x squared. So in this case, we need to adjust a little bit. Okay, by setting the U square. We start with the U square. Okay, set the U square to be 16x squared. Another to say the U is 4x. And then we need to replace the x with the U by differentiating the U with respect to x. Du dx is 4. So du is 4x. Okay. Or what is the du? Du is 1 on 4x. Let me write down. So again, U is 4x. Okay. So du dx is 4. We need to replace dx here. Dx is du over 4. So 1 on 4, we put it up front. 1 on 4. And then 1 over, replace this value, which is the U square. And we have du. Okay. And then only we can compare to the above formula or the above format. It looks like format number 2. Format number 2. Such that our A square is 5. So A is square root 5. And the U square is in terms of the U. Okay. So then we can put the answer. The answer for that integral is inverse sine U over A. So U over A is square root 5. But don't leave your answer as a variable U. So replace back your U. U was 4x. And that is our final answer. Easy, right? So in your formula list, this is the formula of the integral. Okay, with that format that we talked about just now. Okay. So you don't need to memorize it because it's given to you. Just need to know how to use it. Okay, so get handy with your formula list. So another question given in our workbook is number D. Okay, how do we integrate this? 5x 11 plus x power 4. If you are to solve this D by using a simple U substitution, for example, let U be, you say like this, can applying your simple U substitution for x power 3 as you replace your dx, which is du over 4x power 3. So as you substitute, okay, you make sure you have to substitute everything. Okay, so here we still have 5x. dx is du over 4x power 3, and u. Up to this level, you cannot integrate just yet. Okay, and up to this level, you will see that there is still x, and as you cut, still have x squared. It will become complicated. So meaning, for this question D again, you cannot use the simple substitution method that we learned earlier. Okay, so in this case, it does not work. So in that case, we have to use another technique. And as we are comparing it to this formula, well, it works. Okay. First, you have to make sure that you get only like 1 over. So let's do this again. Okay, erase this. So the simple substitution does not work. You see that? Alright. Okay. So to get to this format, you might like to simplify by recognizing what will be the u. So let's say the u square, okay, the u square, this format, the u square, let the u square being at power 4, meaning the u is x squared. We need to replace the dx, so we differentiate to x. And we have to make sure that we can cancel off the x. Here we have 5x dx. So meaning, as we're rearranging it, x dx is actually du over 2. X dx is actually du on 2. So as we substitute, okay, now we have 5. We'll bring it in front the 5. And then we have x dx being du over 2. And then we have this 11 plus x power 4 just now is the u square. And if you're rearranging it, you get 5 over 2 square root 1 over 11 plus u square du. Then you get this format. Okay. This format, as we are comparing it, it is a form of form number 1. 1 over a square plus u square du. So you just need to recognize what is the a square. A square is 11. Another way to say a is square root of 11. Okay, after you have got this format in the form of 1 over a square plus u square, a is a constant, then you can put the answer. 1 over a just now is square root 11. 5 on 2, we put it outside. Okay, constant. And then we have inverse tangent u. What is the u? U is x square. Okay, and over a is square root 11 as we are replacing it. So that you just need to know how to compare, which formula to compare. Okay. So let us do more.